In this video, we are going to review naming of tertiary compounds which contain a polyatomic ion. So some compounds contain ions that are made from more than two atoms, and these are called polyatomic, where the poly means many and the atomic means atoms. An example would be calcium carbonate, which is found in chalk, contains one calcium cation and one polyatomic ion called carbonate, which is CO3 with a 2 negative charge. Now again, you are responsible for memorizing the following polyatomic ions and their valence values. So looking at this chart here, we'll start with the one polyatomic ion that has a positive valence, a +1, is the ammonium polyatomic ion, NH4+. Polyatomic ions with a -1 valence are cyanide, chlorate, nitrate, hydroxide, bromate, and iodate. With a -2 valence are carbonate and sulfate, and finally with a -3 valence is just phosphate. So you do need to memorize these. In terms of naming polyatomic compounds, basically a polyatomic ionic compound is going to contain a cation, or the metal, and an anion, which is the polyatomic ion. Sort of the only exception here is if we have the ammonium ion, which acts kind of like our metal. So these compounds are named in the same manner as binary ionic compounds. And when we're given the formula, we're going to name the metal, and then we're going to name the polyatomic ion. But we're not going to do anything to the ending. We're just going to leave it as such. And also, if there's a metal that's multivalent, we, as we've done before, need to indicate its valence using a Roman numeral in brackets. So looking at the first example, K2SO4, our metal, K, is potassium, and the SO4 we need to recognize is our sulfate ion. So this would become potassium sulfate. In our next example, we've got copper and we've got nitrate. Now nitrate has a -1 valence, meaning that our copper is +1. And since copper is multivalent, we need to indicate this, so that becomes copper 1 and nitrate. When you're given the name, what you're going to do is determine the element symbol for the metal, and for the polyatomic ion, we're going to figure out the valence values for both, crisscross those valences again, and then we need to use brackets if we have more than one polyatomic ion. So let's do two examples. We'll do calcium carbonate. So calcium is Ca, carbonate is CO3. Calcium is +2, the carbonate is -2. If we crisscross those down, you would get Ca2, CO32, which is just going to reduce to CaCO3. Our second one, aluminum sulfate, let me just do it up here so I've got more space. We've got aluminum, which is Al. Our sulfate is SO4. Sulfate has a -2 valence. Aluminum is +3. So we're going to crisscross those down. And that's going to give us Al2 bracket SO4 bracket 3. Okay? Brackets absolutely mandatory if you have more than one polyatomic ion. If you were missing the brackets, then you would basically be telling me you have 43 oxygens in this compound, which really just doesn't make sense. So next what we need to do is talk about oxyanions. So an oxyanion is a polyatomic ion that contains oxygen. And when we're naming with oxyanions, we need to be careful, really careful with our naming. So basically these oxyanions are derivatives of our polyatomic ions that we just looked at. So for example, if we look at chlorate, we know that it has a formula of ClO3 and a 1 negative charge, or a -1 valence. Now, its related oxyanions are based on either adding or taking away oxygens from this main polyatomic ion. If you were to add one more oxygen to the formula, so that would be ClO4 minus, then we need to change the name to indicate that. And the way that we do that is we use the per in front of the chlorate to say that there's one more oxygen. So ClO4 minus would be a perchlorate. If you had one less oxygen, so ClO2 instead of ClO3, then you still use the chlor, but you change the ending to ite. So it becomes a chlorite instead of a chlorate. And finally, if you have two less oxygens than the main ion, so instead of ClO3 you have just Clo, then you need to use the hypo in front of the name with the ite ending. So this would be our hypochlorite ion. Now, in terms of trying to memorize some of the polyatomic ions, I do have a simpler way to memorize the main ones, using the saying, Nick the camel ate a clam supper in Phoenix. So the way that we use this is that the first letter of each of our main words tells us what the first element is in our polyatomic ion. So that means Nick relates to nitrate or nitrogen. Our C is carbon, so that's our carbonate. Our Cl is our chlorate. S is our sulfate, and F is our phosphate. Now, we know that it's made up of the element combined with oxygen, so we're going to write that down. And then we're going to count the number of consonants. In Nick, there's 3. There's N, C, and K, and that's going to tell us how many oxygens are in the 8 ion. So 3 consonants means we have 3 oxygens, and then we're going to count the number of vowels. So only one vowel in Nick, meaning that it has a -1 charge. So if you did the same with the next, I'll just show you the next one, camel. So we know that's carbon. We know the second element's oxygen. There are 3 consonants, so C, M, and L, telling us there are 3 oxygens. And there are 2 vowels, A and E, meaning that it has a 2 negative charge. A little trick with the clam one, this is for chlorine or the chlorate, but you can get all of the other halogen ones from the same thing, because they all have the same general formula. So a bromate would be BrO3 minus, an iodate would be IO3 minus, a fluorate would be FO3 minus. Okay, so they all follow the same general formula, same general pattern. So let's just finish off. Sulfate would be SO4 and then 2 minus because there's 2 vowels. And then Phoenix would be PO4, 3 minus.